So we've talked about the laws of sines. Today we're going to be talking about laws of cosine. Now you're probably thinking, why do we need another formula to solve for triangles? Well, that's because the law of sines only works when you have two angles. In other words, when you have side, angle, angle, or angle, angle, side, or when you have angle, side, angle. So maybe the side is in between the angles, or when you have an ambiguous case. And this is very particular, it has two sides, but it's the ambiguous case. It helps you find the other second angle. So unless you have these three cases, you're recommended to use the law of sines. But if you don't have enough angles, you might not be able to use law of sines. So in this case here, let's say you have a lot of the sides of the triangle. In other words, maybe you have two sides of the triangle, or you have all sides of the triangle. So you would use the law of cosines when you have a triangle that is side, angle, side, or maybe just all the sides, so side, side, side. So if you look at this formula, you can see that the formula has a lot of the sides that you can plug in, and then you can find the angle. And this formula has cosines instead of sines. And if you really dive in deep and you want to construct this formula from scratch, you will realize you're using the Pythagorean theorem or the distance formula to help derive this formula. Now, we're not going to derive it here, but you can definitely watch some YouTube videos. It's pretty cool how the formula is derived for laws of cosines. So in order to use this formula here, you're going to need to have at least two of the sides. It'd be even best if you had three of the sides, so you can go ahead and plug it in and find an angle. So because majority of what you have in the triangle is the side, so let's say that the side is A, B, and C, and this is your angle A, this is your angle B, and this is angle C. So if you have majority of the sides, you're probably going to be looking for the next angle because you're deprived of angles. Here's the thing. When you have a, let's say a side, angle, side, let's say you have a side, angle, side, or side, side, but let's constrict the matter and use a side, angle, side. So you have fewer sides to work with. And so I'm going to make up a triangle. Let's say you have one of the angles and then two of the sides are between the angles, as you can see the formatting. So let's call this side 7 and this side 10. Like, where do you start when it comes to finding the angle? Should you go for finding this angle first or this angle? Like, how do you know which one to start? Or better yet, does it even matter which one you start to find? So it kind of does matter which one you find, because if you're not careful, sometimes you can step into an ambiguous case. And here's why. So when you're looking at the sides, you have a 7 and a 10. When choosing which angle to find, let's say I were to choose the bigger side, the 10. Then that means this angle here could be the biggest angle, but I don't know for sure because I don't know what's the side length here. If this side length ends up being the bigger side length, then this shouldn't have been the bigger angle. And so I'm not going to choose the bigger side here because I'm missing a side. Instead, I'm going to choose the smallest side. If I choose the smallest side, that means that the angle across from it has to be the smallest angle or has to be acute. I know I can guarantee myself if I pick the smallest side, so smallest side, then the angle across from it has to be the smallest angle. In other words, it has to be an acute angle. So find this angle because it's acute. It has to be acute because it was the smallest side between 7 and 10. So even if this side was smaller than 7, 7 would still be an acute angle that's produced here. So if this side was, 5, then this would also produce an acute angle. But what I'm trying to do is guarantee that the angle I find is acute. So essentially, when you are trying to figure out which angle to find, you should always start with the smallest side. That is the key part. And I will reiterate this as we're going through examples. So let's do example 1 together. So example 1, you're given all the sides. So you are given a side, side, side triangle. And you're asked to solve for it. So you have to find all the sides and all the angles. So as I always say, make a list and organize what you're given so you can kind of keep up with things here. So you're given all the sides. So we can fill that part out. So it's given, A would be this guy here directly across from it. So 8 centimeters. B is going to be 18. So B looks like it's the biggest side, and C would have to be 12 centimeters. All right, so what I'm gonna always do first when I'm choosing the angles is pick the smallest side. So the smallest side here is A, so I know that A here, the angle, has to be an acute triangle. So I picked out the smallest side, and I'm gonna choose to find this because this has to be an acute angle. So if I don't get an acute angle, then I have to subtract it from 180 to get the acute angle. See what I mean there? So I'm guaranteeing myself what this angle is supposed to be. All right, so let's get started here. I'm going to set up the equation, and this is the part where we're going to apply the new formula. So if you look above, if I want to find angle A, which one of these equations has a big A or an angle A? Well, it's the first equation. So the first equation has angle A, so I'm going to copy and paste that down below so we can see it together. So that's going to be A squared equals B squared plus C squared minus 2BC. You'll notice all the formulas are pretty much the same, it's just the variables are rearranged differently depending on what you're given. So my A here that I'm plugging in is 8. My B is 18, and I have to square it, and my C is 12. Then I have to plug in B and C again, so 18 times 12. And cosine of A, I don't know what A is. So this is what I'm going to try to get by itself. So first things first, I am going to try to multiply or square these so I can start moving things over to the other side. So 8 squared is 64. You might need a calculator here because I don't know what 18 squared is, but your calculator does. And so that gives us 324. 12 squared is 144. If I multiply all these numbers, 3 times 18 times 12, that gives me 432. Cosine of A just drops down, and maybe I can add these together first, but do not add it or subtract it from 432 yet because it's attached to cosine of A. So I'm only going to combine these two first, and that gets me, let's see, 324 plus 144 gives me 468. Drop down the cosine and the 432. Now I'm going to try to get cosine by itself, so maybe I'll subtract this off to start moving things over to the other side. So this can wipe off. Negative 432 cosine finally drops down, and 64 minus 468 is going to give me negative 404. All right, this number is attached to the cosine using multiplication, so I'm going to undo it using division. And we're going to divide it to the other side as well, so that cancels. We are almost there. Cosine of A just dropped, and then I have to plug this into the calculator. So two negatives make a positive. If I divide 404 with 432, I get about, let's round to 3 decimal places, so 0.935. All right, this is the part where you want to take the inverse of cosine, so that way you can find the angle. So if I were to plug in inverse of cosine 0.935 into my calculator to find A, I'm going to round to 3 decimal places. So that would be 20 degrees, 0.772. And that is in degrees. So make sure you're in degree mode when you plug this into the calculator. So I found my angle A. That's great. So now I can put this here as my angle. And notice it is acute, which is good because I needed an acute angle because this is the smallest side, so it should have produced an acute angle. Now, if it didn't, if it was obtuse, I can just easily subtract it from 180 and find the other triangle that would have been acute. See what I mean? You always want to find the smaller sides because you can guarantee that it's acute. So now let's go find the next angle. So you found A, which one should you find next, B or C? Well, I think it's probably best to just go find the next smallest side because you can probably guarantee yourself that that has to be acute again. So always just go from the smallest to the next smallest. So in this case, our next smallest would have to be 12 here, not 18. So 18 will give me the biggest angle. So I'm going to go after C next because that would be the next smallest. So if I were to set up that ratio, I already have A. So I can say that using law of sines, this is 8 over sine of 20.772 degrees is equal to C, which is 12 centimeters over sine of C, which I don't know the angle of, but I'll find out. So I'm using law of sines now because I already have one of the angles, so I can definitely use law of sines. So given that here, if I were to find C, I could try to cross multiply. Might be easier to do it that way. So I'm going to multiply diagonally, which is called cross multiplying. So this would give me 8 sine of C. If I multiply 12 to this side, the 12 would just go in front. And then I would just divide off 8 to cancel out that piece. Sine comes down. And then I would multiply this out, 12 times sine of 20.772, divide by 8, and just round to 3 decimal places. So if I put this in my calculator, I get 0.532. So I can take the inverse sine of this and plug that in one more time. And my angle ends up being 32.141 if I round to 3 decimal places. All right, so now I have angle C, so 32.141. And so again, I should have also gotten acute angle, and I did. And to find angle B, well, that's our last angle. And this part's a lot easier to do because as long as you have 2 angles, you can find the last angle by just subtracting it from 180. So if I just wanted to find angle B, I would just take 180. Oh, by the way, this symbol right here just means angle. So if I want to find angle B, I would just take my 2 angles that I found, so 20.772 and then 32.141. If I subtract all of this, I get 127.087 degrees. And that is my angle for B. And it is the largest angle. It's actually obtuse. And so one of the things you have to know about the calculator is it's not going to ever give you an obtuse angle. In fact, in order to get this angle, you would have to subtract it from 180. So that's why I always try to find the biggest angle towards the end because I'm going to have to do it at the end anyways. All right, so I found all my angles and I had all my sides, so I'm done. So key component here. When you're starting to find your angles, pick the smallest side to work with first. Find that angle, and then once you have an angle, use law of sines to find the next angle until you get all of them. All right, let's try out example B here. So with example B, we have a angle and we have 2 sides. So this might be like a side angle side, but I'll draw a picture so that way we can see what type of triangle it is, just to get some clarity. So if I draw a triangle here, and I'm not drawing it up to scale, so let's say this is A, B, and C, and this is 108. I don't know what A and B is, but I do know B's side, which is 7, and A is also, looks like B is 7 and A is 10. I don't know what C is. So in that case, I do have a side, angle, side. So this is a side, angle, side. So I'm definitely using law of cosines here because I have 2 of the sides. In that case, let's organize what we have. So we need to find angle A, B. We have C, which is 108, which is good. We have side A and side B. It's in centimeters. We don't have side C, so we'll have to go get that. So let's start by maybe finding the missing side here. So that way we know which one's really the smallest side. So to find C, if we look back at our law of cosines here, little c has its own equation. And it says you can find C if you have A, B, and the angle C. So I'm going to take this formula and paste it to our problem that we are encountering. So I'll put it to the side here. So it says C squared, or the side C, is equal to A squared plus B squared minus A2. Basically, whatever these two are, you're going to be multiplying it by 2 off to the side, and then it's cosine times whatever this side's angle is. So this is going to be C here. And that's nice because we already have this angle C. So I'm going to plug in what we know. So we don't know what C is. That's okay. We're going to find it. A is 10, B is 7, and then A is being plugged in again. So 10, 7, cosine of C, which is 108. Once I plug everything in, you can actually type all of this into the calculator, but be careful with order of operations. So you might want to just take it slow and then type it into the calculator. So 10 squared is 100 plus 7 squared is 49. 2 times 10 times 7 gives me 140. And then this is still C squared. So I'll just bring that side down. If I add the 100 and the 49, because they're like terms, I'd have 149. And this is the part where I probably plug all of this into the calculator. Shouldn't be any issues because there's no more exponents. So I'm taking 149 and I'm subtracting it from this product here. So if I round this to 3 decimal places, I would get 192.262. So now I can take this number and take the square root of it to get rid of the square. So I'm taking a square root so I can get rid of the square. I have to take the square root of the other side. So C is approximately 13.866 if I round to 3 decimal places. So 13.866 centimeters. Now at this point, we can evaluate which side is the smallest, and it looks like it's B. So perhaps let's start with finding B's angle, because that one has to be smaller than C for sure, because C is way bigger than B. So if we were to find angle B here, let's set up a ratio using law of sines. So C here, let's put this to the side here. So we need side C, which was the 13.866. And we're putting this over sine of 108. And this is equal to our B ratio. So B was 7 centimeters, and the angle we have not found. So we're going to try to find angle B. And we can cross multiply here since the sign is in the variable we're trying to find is in the denominator, so it might be easier to just try to get rid of the fraction. So if I were to do this, I would have 13.88 times sine. So I'll just put that in front of the sine. Oops, I meant to write 2 6s. And then 7 times sine of 108. If I divide off this 13.866 to both sides, I can try to get sine by itself. So I have sine of B here. I'm going to plug this into the calculator, and if I do and round it to 3 decimal places, I get 0.480. And then I'm going to just take the sine inverse. And this is B that comes down. So B comes down, I'm going to plug this into the calculator, and I get 28.685 degrees, and I have the angle for B. And it is acute. So this angle here will be my second angle. So 28.685. Fix that real quick. All right, so everything looks good so far, and I just now have my last angle. So I can take 180 and subtract it from both of these angles, and I should get my last angle. So if I want angle A, I would just take 180 and subtract it from my two angles that I had. So subtract it from 128.685 with 108. My angle A is 43.315 degrees. All right, let's double check everything before we end this problem. So I always like to correspond the length with its angle. So smallest side should have the smallest angle, which it does. B is the smallest side and has the smallest angle. C was the largest, and it also has the largest angle as well. So everything corresponds nicely with each other, so we're probably on the right track. Okay, so we're getting into C here. So final problem before we get into the story problem. So this one here, you're given all the sides. This one's a little bit different because you're given more decimals, so you might have a little bit more finicky numbers, but that's perfectly fine. We have a calculator. So because you're given all sides, I don't need to draw the triangle to know that you have a side, side, side. So let's write down what we're given. So we don't know any of the angles because this is given just the sides of the triangle. So let's label down what we have. And you should be thinking about who's your smallest sides. The nice part about side, side, side is that as long as you pick the smaller sides, like A and C is smaller than B, you should know that you will always get the acute angle. So I could actually choose angle A to solve for, even though C is smaller. Now, probably a safer way is to always just go with the smaller one, but I'll show you that this will work if I were to just find angle A instead. Because as long as you choose the ones that are smaller than the bigger one, you will get an acute triangle. This one here, I'm probably not going to choose to find until the very end. And that's because I don't know if this is going to produce an obtuse angle. And if it does, I have to subtract it from 180. If I'm not careful, I might forget to do that. But if I leave it towards the very end, I'll always remember to subtract all my two angles from 180 anyways. So I'm going to save the largest side for last, and I'll just go with the smaller sides. So I'm going to just choose A, but I could have chosen C. It's pretty safe as long as you're choosing the smaller sides. So if I were to choose A, just to be a little bit different this time, let's figure out which formula that I would need to use. So if I want to find angle A, I need a formula that has big A in it, which would be the first formula here, had big A. So if I choose the first formula, let's copy and paste that here so we can see it together. That would be A squared equals B squared plus C squared minus BC cosine of A. Okay, so we're going to plug in what we know. We know little a, which is 4.2. We're going to need to square it. B is 5.4. That's going to be squared. C is 2.1. That's going to be squared. Times 2 times my B, which is 5.4. And my C is 2.1. And I don't know what my angle is. So that's the part that I need to find. All right, so this is the part where you're definitely going to need a calculator. In fact, I don't know, this would take a while if you didn't have a calculator. So make sure you have some calculator to square these numbers. So 4.2 squared is 17.64. 5.4 squared is 29.16. And then 2.1 squared is 4.41. And I'll drop down the minus sign. So if I multiply all these three numbers, 2 times 5.4 times 2.1, I get 22.68. Cosine of A just drops down. And again, I can add these numbers first because they're like terms. So I'll just drop down the 17.64. If I add these two numbers, I get 33.57. And I'm going to drop down the cosine of A. So from here, this part's attached to one another, so I might just remove this to the other side by subtracting it off. So this is getting rid of, and then I'm going to move down the 22.68. So if I take this number and subtract it from 33.57, I get negative 15.93. And so I can divide it from negative 22.68 on both sides. So this helps me cancel things off. Cosine drops down. And I just need to plug this into my calculator and round. And I'll round to 3 decimal places like usual. So this ends up being a positive 0.702. And to get rid of cosine, I just have to take the inverse. So plugging this into my calculator, I get 45.412 degrees. And this here is an acute angle, as you can see. So I'm going to put that in for A, 45.4120. And now I'm going to go find, let's go find angle C, the next smaller angle. So I know that C also has to be acute because it is the smallest angle here. So I'm going to find that one next, but I don't have to use law of cosines anymore or this strenuous formula. I can use law of sines now. So the ratio that I can create is using A's since I have the angle and the side. So let's create a ratio for that. That would be side A, which is 4.2 over sine of 5.412. Oops, forgot the 1, 2. And then this side is 2.1 sine of C. So this is side C, and then angle C is what I'm trying to find. So again, the variable is in the denominator, so I might want to cross multiply with this one. And this would give me 4.2 sine of C on this side, 2.1 sine of 45.412 on this side. I need to divide off 4.2 to cancel out that piece, and then sine of C comes down. And I'm just going to go ahead and plug that into my calculator. So that's going to be 2.1 times sine of 45.412. Divide that by 4.2. And I get about 0.356. So I'm going to take the inverse sine and get my angle C. So angle C should be a very small angle, an acute angle, and it is. So I get 20 degrees 0.855 if I round to 3 decimal places. So I'm going to take this angle and put it to my list. So hard part's over. We have angle C, our second angle, so 20.855 degrees. To find angle B, all I have to do is subtract it from 180. So angle B is going to be 180 minus 45.412 minus 20.855. So if I plug this into the calculator for 1 minus 20.855, I get 113.733 degrees. So 13.733 degrees. And let's just double check things. So my largest side did get the largest angle, and turns out it is an obtuse angle. And my smallest side has the smallest angle. So everything looks good to me. And there we go. All right, so kind of key things here. When you're given a side, or a side, angle, side, I recommend always finding the angle that had the smaller side because you only have two sides to choose from. Pick the smallest side first to solve. If you're given side, then it doesn't matter which one you choose to solve. Just don't choose the largest angle to solve first. I recommend choosing one of the smaller sides to solve first. All right, that is it for this video. In the next video, we'll do the story problem.